Most people picture an AI agent as a magic assistant that simply knows what to do. Behind the scenes, it is usually a loop of small decisions, tool calls, checks, and retries. That loop matters because the model can sound confident while still choosing the wrong tool, missing context, or believing a failed action actually worked. If you understand the loop, you stop asking, "Can this agent talk?" and start asking, "Can this system decide safely, call tools correctly, and stop at the right time?" In this video, I will walk the loop step by step. Receive the task, understand intent, plan, choose a tool, execute, observe the result, and either continue or stop. We will use one practical engineering example all the way through. Imagine an agent asked to investigate why a cloud deployment failed and prepare the next safe action. That example is useful because it forces the agent to read context, inspect logs, choose tools, handle permissions, and resist the temptation to invent progress. I also want to separate the model from the whole agent system. The language model is the reasoning engine. The agent is the workflow around it. By the end, you should be able to sketch the loop, name the common failure points, and explain why production agents need validation, guardrails, and auditability. A chatbot mostly waits for your next message and returns language. An agent is different because it can keep working toward a goal across multiple steps. That does not mean the agent is conscious or independent. It means the system has a loop. Take input, reason about state, decide the next action, and read the result. In practice, the agent usually has 4 things around the model: task context, working memory or state, tool access, and stopping rules. Once those pieces exist, the important question is not whether the model sounds smart. The real question is whether the loop keeps the system grounded in reality. Step 1 is receive task. The system gets a user request, event, or queued job. At this point, it still has words, not a reliable plan. Step 2 is understand intent. The agent tries to extract the goal, constraints, success criteria, and permission level. Missing context often breaks the loop right here. A strong agent does not rush past ambiguity. If the task says fix the deployment, it should ask whether that means diagnose the error, draft a fix, or actually apply changes. Step 3 is plan. The plan may be one step or several, but it should convert the vague request into a small sequence of checkable actions. Step 4 is choose tool. The agent decides whether the next move is to search logs, query an API, open a file, call a database, or simply answer with no tool at all. This is where wrong tool choice shows up. If the task needs current deployment logs and the agent chooses stale memory or the wrong environment, the rest of the loop starts from bad evidence. Step 5 is execute. The agent builds a tool call or API request, sends it, and waits for a response. Now the system finally meets the outside world. Step 6 is observe result. The agent reads the output, checks whether it answered the question, updates state, and decides whether to continue the loop or stop. One common failure is bad API output. The tool returns malformed JSON, partial data, or an error page, but the model still tries to summarize it as if it were valid. Another failure is hallucinated action. The agent says it updated the ticket, restarted the workload, or saved the file even though the tool call never succeeded. Timeouts and permission errors are also normal production realities. A tool can hang, rate limit, or deny access, and a safe agent must treat that as a real state, not an inconvenience. Missing context may be the most expensive failure of all. If the agent cannot see the right files, prior messages, environment, or approval scope, even good reasoning leads to the wrong action. A safer agent architecture makes every loop step explicit. It validates inputs, uses typed tool schemas, records tool responses, and separates suggestions from real side effects. It also carries a policy layer. Read-only tools may run automatically, but destructive actions like changing infrastructure, closing incidents, or applying Terraform should require review or approval. For engineering work, I like a simple rule. AI can investigate, explain, draft, and prepare. Humans or tightly governed systems should approve risky state changes. When you add retries, time budgets, fallback paths, and stop conditions, the loop becomes far more trustworthy because the agent knows how to fail safely. So behind the scenes, an AI agent is not one answer. It is a repeated loop of intent, planning, tool use, observation, and decision. If you remember one mental model, remember this. The model proposes the next move, but the surrounding system decides what is allowed, what is true, and when the work is done. That is why the best agent demos show the loop and the guardrails, not just the final response. Production value comes from controlled execution, not from impressive wording. At Trustscrin, we are building tools around this problem, and I will show more in future videos. If you want more practical cloud and AI engineering breakdowns, subscribe and follow the next lesson.